Okay, for number 10, I'm going to go to the whiteboard, and I probably should just do other problems too, but I know I've been jamming things in, and sometimes just get a clean sheet of paper and do it on a clean sheet of paper. So let's go to the whiteboard. Let me write down the integration for you. This is number 10, the last problem in the set. And let's go backwards 1 second. So it's number 10, and what I see is it goes from 1 to infinity, and then I see the natural log of 2x over x squared dx. One thing I'd recommend do is, one is know it's improper. And why is it improper? Because we're going off to infinity. So at a minimum, you should know that this should be written as limit. I'm going to put an a down, goes to infinity, and it's going to be 1 to a ln 2x over x squared dx. So that's something I have to do. But the problem is I don't know the antiderivative. So what I want to do is I want to go through that. All right, so I need to do that. I'm going to do an indefinite integral ln 2x over x squared dx. I'm going to use integration by parts. I'm going to say u equals the natural log of 2x. That means du is 1 over 2x times 2, which is 1 over x dx. This forces me to choose that dv is actually x to the minus 2 dx, which means v is going to be minus 1 over x. Again, increase it by 1, minus 1, divide by minus 1. You're okay. Plus c, but I'm not going to worry about that. So what do you do over here? Let's write this down. It's going to be uv, so minus natural log of 2x over x. That's uv, minus the v du. Let's see, plus 1 over x. That's the v part. And the du is 1 over x dx. Let's keep moving along. Minus the natural log of 2x over x plus, well, that's going to be an integration x to the minus 2 dx. I think I can do that. And what do you get? Minus the natural log of 2x over x. Increase the exponent by 1, so it's going to be x to the minus 1. Divide by minus 1, you get plus, I'm sorry, not plus, but minus 1 over x. All right, so, oh, by the way, plus a constant of integration. I'm not too worried about that. So, I got that, and I wondered, does it help me at all? I don't know. We'll go back up here, and I'll write this down. So it's going to be limit as a goes to infinity. I just did a bunch of work, and I'm going to pop in an a now. So minus ln 2a over a. I'm just popping the number in, right? Minus 1 over a. That's the upper limit. Minus the lower limit, which doesn't look that bad to write down. So it's going to be minus ln, well, 2 times 1 is 2. And then 1 squared is 1. Minus 1 over x, which is going to be 1. All right, so it doesn't look that bad to do. And what I mean by that, I'm going to do this part first because it's so easy. Nothing to do with a. So what do you go there? Let's see, ln 2 and plus 1. Now when I do this guy over here, I want to point out that the bottom grows much faster than the top. So that's going to be 0, and that's going to be 0. So this is my answer. What do you do now? I'm going to go back and look at the key at this point. I'm really not looking through the work, by the way. I'm kind of looking at the answer, and that's really like, a traditional thing to do is just look at the answer. Did I get the same answer? And I see ln 2 plus 1. So they got it written down in different order, by the way, but that doesn't matter. Additions are commutative, so 1 plus the natural log of 2, it's really the same thing. All right, so I did good there. What I want to claim over here is when you're studying, though, it's really important you start to look at the key, all right? making sure you can agree with what's written over here. What's the difference in the key? They're using the letter R where I'm using the letter A, all right? But we got the same answer. The work relatively similar, all right? Thank you.